Ladies and gentlemen, welcome to another session of Nambane Academy, Grade 12 Physical Sciences. We are currently busy with work, energy, and power. We did now explain concepts in detail, and a homework activity was given for one to do so that you can have reference in terms of what is it that you did not understand, what is it that you actually understood. And with that being said, thank you very much for the commitment you showed. I received the homework activities. I went through them. I still believe there are few things that we can fix. So have your answers while I explain and check what is it that we did, because it's a school holiday kind of thing. I don't want to keep you long. A maximum of 1 hour 15 minutes will do. The reason is that I also one person who believes that as learners you still need to now to rest. So I'm not going to take long off of your time. And the other part is sorry for yesterday. Unfortunately, this is South Africa, so when we have power cuts, we have all this load shedding and things. Unfortunately, at times they are unavoidable. But I'm investing in a device that I can be able to use regardless of power cuts or load shedding. So that will be sorted in the next few weeks. So without wasting any time, we explained all these concepts. You did get the notes thereof, and we went and explained in terms of the summary, so I am not going to bother you with that. We did now question 15 as an example of how to apply the principles and everything like that, and this was the homework activity that was given to you. So I am quickly going to do it with you. Check your answers against mine. Ask where you did not understand. Let me not waste time with 16.1, because the question says an object of mass 1.8 kg slides on a rough curved track and passes point A, which is 1.5 meters above the ground at the speed now of 0.95 meters per second. The object reaches point B at the bottom of the track with a speed of now 4 meters per second, and the diagram is exactly illustrating that. So the mere fact that I am told that there is a rough surface, automatically it says there is a frictional force. Clear. Those are now keywords that I need to look for. The other words is just data, which is the mass, speed, height at A. So we are going to need that information thereof. 16.1, it is a definition. What did we say about a definition? We said definitions are non-negotiables. So a definition in this instance, it says define the term conservative force. A conservative force is a force for which work done in a moving object between 2 points is independent of the path taken. And I must emphasize that now this is either 2 or 0. It's either you get it right or you don't get it right. So this one, ladies and gentlemen, it's definitely 2 or 0. So the fact that it is 2 or 0, it basically says to me it is important for each and every one of us to know the definitions. So the definition, I was very happy you got it right. So name at 16.2, name now the conservative force acting on an object. The conservative force acting on an object, it is a gravitational force. Your Tapelo, your hand was up. Tapelo, your hand was
So
up.
it was me.
Oh, it was
Was
Tate Sekwi. Okay, sorry. Sekwi.
so my definition to use is different, sir. Like
Yes,
it's similar, but it's different.
it's similar but it's different.
Yes.
Let me read it out quickly so that we can sort it out. It says a force which in work is done is independent of the path taken due to the gravitational force. That one, it is a definition from a textbook, I want to believe.
Yes, sir.
Thank you. So now remember I said now we want the science to be universal. So if we want the science to be universal, we are going to use this what is now shared with you to say, let's only use the definitions that now appear in the examination guideline that appears now in the first stage. We have what we call terms and definitions. So I gave you that through the website. So let's stick now to only having this as our platform for definitions. Because now let's check what you said, Mr. Sekwi. It says independent of the path taken due to gravitational force. That is not true because why? Because now gravitational force is associated with what? It is associated with a conservative force. So let's use the definitions as they appear in this document that I shared with you. Because now what the examiners are looking for is a force which work done in a moving object between 2 points is independent of the path taken. So by the fact that you added due to gravitational force, it basically says it means now you are somehow trying to combine a definition of non-conservative as well as conservative, because conservative is an example, gravitational force is an example of a gravitational. Okay, we lost a couple of people in this meeting. Let's wait and see. Thank you, Tateseku, you are back. And then Tapelo is back. So it's the internet, but that is not a problem. So I was saying, Mr. Sekwi, let me share the screen again. Can you see the screen, gentlemen?
Yes, sir.
Thank you. Then let me move and say fine. Now let's use the definitions as given in the exam guideline. Thank you. Happy Mr. Sekwi. Are you still there, gentlemen?
Yes, sir. We are.
Okay. Seems like this thing is very slow now. Okay. Let's move to this. Fine. So like I said, sorry, this definition will be now 2 or 0. So it is important that we know our definitions. At 16.2, name the conservative force acting on an object. That should be now the gravitational force, or one can easily use the word weight. That will also accept. Then that becomes your easy 1 mark. At 16.3, is the mechanical energy conserved as the object moves from A to B. Now remember, A to B This is a rough surface, which means we have now friction. And once we have friction, it basically says the mechanical energy, it's not conserved. So we can easily go to 16.3. Let me use black to say fine. No, it is not. And then that is a mark. By confidently knowing that once friction is there, the system is not isolated. And if the system is not isolated, it basically says there is friction now. So this one you got it right. I am very happy. Mr. Sekui, your answer said there is a non-conservative force. I don't have a problem with that. Let me check the answer from Tapelo. Where is it? It is here. Okay, wait. It is here. Okay, fine, Tapelo. Yes, I don't see your answer here, but I remember you sent me something yesterday. Let me quickly check. Okay, no problem. But it is important to actually say which force it is. If you say there is a non-conservative force, I agree because friction is there. But in the near future, let's try to be specific and just tell them that there is friction. By saying non-conservative force, you are basically opening it up to say there is tension, there is air resistance, there is friction. So at times we need to be sure of the answers that we are giving. So by saying there's non-conservative force, I will argue it and give you a mark because friction is a non-conservative force. But it is wise and advisable for one to say exactly what or which non-conservative force is there. So that will give you now the nice 2 marks that we intend on as heavy. At now 16.4, calculate the gravitational potential energy of the object when it is at point A. Now let's check what is happening at point A. At point A, we have the mass, which is 1.8 kg. We have the height, which is just 1.5 meters. We also have the g, which is 9.8 meters per second squared. Can we just easily say EP is equals to mgh? 100% we can do so. Is equals to 1,8 multiply by 9.8 multiply by the height, which is 1.5 meters, and this will give us something like 26,46 joules, and that is how we get the 3 marks. But remember, we only get the mark for the formula provided we attempted to do a substitution. You only get the mark for the final answer provided you have the correct SI unit. That will give us the 3 marks. So if you do not have the SI unit, unfortunately, you do not get the mark for the final answer. So it is important for one to know that formula, substitution, answer with the correct SI unit. I didn't see anyone having a challenge there, so I am very, very happy. And thank you very much for that. At 16.5, use now energy principles to calculate the work done by friction on the object when it slides from point A to point B. Friction is there. very happy. We have three energy principles: work energy theorem, conservation of mechanical energy, and work done by non-conservative force. So obviously, principle of conservation of mechanical energy will not work because there is friction. So the first option will be work energy theorem. Why? Because it always works. That is what we said. Secondly, we can use now work done by NC. So I am going to try and do option 1 and option 2 just to show that we can easily be flexible in terms of how to go about this. Let's try work done by non-conservative force. The formula says it is now changing EK plus changing EP. And what is now work done by NC? The NC that we have here is just work done by friction. That is the only thing we have. We did not have to draw a free body diagram. Why? Because we are only focusing on the frictional force. Then we move to say, fine, half mv squared final minus half mv squared initial. This is the first part of the change. Plus mgh final minus mgh initial. That is what this change basically means. So what must one do now? It is just a matter of substituting the information that is given. Half of 1,8, that is the mass, multiply by 4 squared, that is now at point B, which is now the final velocity, minus half of 1.8. What is the initial velocity? 0.95 meters squared. So this is now the first part. Plus now, what is the mass of the object final? It is 1.8. What is the gravitational acceleration? 9.8. What is the height now at B? It's 0. And now we can just say plus, mg, which is 1.8, multiply by 9.8, multiply by 1,5, which is actually what we calculated at 16.4, because 16.4 actually represents the initial gravitational potential energy. So with that being said, ladies and gentlemen, I am almost now 90% correct because I used the correct principle. I am substituting the values that the examiner did not give me. So if it happens that the examiner does not give you something, it basically says it is going to be a multi-step type of a question. What is a multi-step? You are going to use a different formula to get whatever you don't have, and then come back now to using the energy principle. So after substitution and the manipulation, you get your final answer as negative 12,87 joules. Why? Because I want to repeat, because work done by friction, we associate it with the cos of 180. And we said cos of 180 is actually giving us a -1. So that means now friction is actually doing a negative work. So if your answer was not negative, then you need now to recheck your calculations and so forth. So that becomes very, very easy to consider. It's very, very important. So This is the basic principle that one can use. And remember, work energy theorem will also work. And work energy theorem will want us now to draw a free body diagram. Yes, we can, but basically we just know that it will be the work done by friction and work done by by Fg, and that will give us the 24,46. Then it becomes very, 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 very easy. So let me pause, give you your 30 seconds to digest now 1.1, 16.1, 16.2, 16.3, 16.4, and 16.5 before we can get now into 16.6, such that I can allow questions thereof. For the sake of time, if you want to, okay, maybe let me just say I will send the solution of using work energy theorem later. That will not be a problem, but the emphasis was, why complicate it when you know that the very best option that you can use, because you have friction only, then you must just use work done by non-conservative force, and everything sits well. So work energy theorem is going to cost you now to identify the forces, even though it will take you time, but you'll still get to the same answer. So let me give you your 30 seconds and then we digest all this. Now, I don't see any hands or comments, so it basically says we are happy with that. Let's move and check now. It says surface BC in the diagram is frictionless. What will be the value of the net work done on object as it slides between point B and C? It is frictionless. So it basically says now there is no friction. It is only continuing to move due to its momentum. That is now another topic that we looked into earlier. So it basically says there's no force acting on it. So if there's no force acting on it, it is moving at a constant acceleration, definitely now at 16.6, then our answer will be 0 joules. It's as simple as that. And this will give you now your 13, 13, 13 marks. That is now the total of the question. So it basically says more practice, more practice. That will now allow us and give us space and time for us to work on this kind of problems. So like I did say, this session is basically for us to practice together, but I'm going to give you another opportunity for you to perform another exam type. Send me your answers and then we later discuss. So let's check what question it is. This is now question 19. So question 19 is about 14 marks. So I will give you 15 minutes for you to perform this one. Kindly send your answers to me again. Then immediately after the 15 minutes, we will be in a position of discussing it. Work it out. Send me your answers. Let me check what is it that you have, and then we can engage with it immediately after the 15 minutes. Any questions, Tapelo?
No, I'm fine, sir.
Thank you. And Tatesekwi, Galeboha?
No, some fun, sir.
Thank you. Then I will be waiting for your answers. Kindly share your answers with me. Yes, Tapelo?
Um,
Yes, I'm listening.
no, sir, not.
Oh, you're not saying anything.
I'm not saying anything.
Oh, okay. Now just kindly switch off your mic then. I don't see your answers, guys. So I'm not sure. Should I give you extra 2 minutes?
Yes, please, sir.
Thank you, Sekui Tapelo.
Yes, I'm about to finish.
Okay, let me give you
I'm
just,
about to send.
all right, let me just give you extra 2 minutes so that I can receive everything you have. Thank you very much. All the answers received. Without wasting any time, then let's get to explain. I see most of you attempted it the right way, but I think the challenge was now at 19.4 and 19.3. Let's not waste time. It says a 2 kg box is released from rest. That information is very, very important. It's released from rest at point P. So we know that V initial at point P is 0, 5 meters above the ground. It slides on a smooth frictionless curve PQ as in the diagram given. State the conservation of mechanical energy. So the conservation of mechanical energy just says the total mechanical energy in an isolated system remains constant or it is conserved. So that is now easy 2 marks. And if you check all these questions that we've been doing, there's some form of an easy 2 marks that one can get in terms of either a law or a definition. Hence, when we started, the emphasis was only solely focused on definitions and laws. Now check here. It is in capital letters. Use the conservation of principle of mechanical energy to calculate the speed of the box when it reaches point Q. The fact that the examiner is emphasizing that you must use conservation of mechanical energy, that is the first thing that we want to see. So at 19.2, sorry, at 19.2, let me use black. So at 19.2, EK plus EP, this is now at the top, is equals to EK plus EP at the bottom, or one can easily say at Q. So depending on the references that you use, but in this instance, our top basically means at P and our bottom basically means at Q. So let's just substitute the values we have. I usually like to say half mv squared, mv squared, and at the top it's initial, that is where it started, plus now mgh is equals to half mv final squared minus mgh, sorry, plus mgh. I usually prefer doing this because by breaking down the formula, I can know what now to substitute. Even though half of the mass of 2 kg multiplied by 0. That substitution is very, very important. That is what the examiners are looking for, that you actually understand the meaning of what it means when we say an object is at rest. Then the object has a mass of 2 kg, 9.8, and it has that height of 5, and then half now of 2, and the question wants us to calculate V final. But what happens now about MGH? It is plus now 2 multiplied by 9.8. What is the height at Q? It's 0. Then after the manipulation and everything else, you find your V final is just equals to 9,90 meters per second. So that was an easy 3 marks, 0,90 meters per second. So that was just a nice, easy 9 marks, 3 marks that one can get. And this makes it very easy because the instruction was very clear. So they are not asking us to use energy principles, but they are actually giving us the principle to use. So hence now it becomes a nice, easy 3 marks for one to get the 3 marks. So for the whole substitution, you get your 3 marks. Now, the box passes point Q and moves 10 meters on a rough horizontal surface. Before striking the barrier at point R at a speed of 4 meters per second. So what do we know? We know that at this instance, V is equals to 9,90 meters per second. We also know that now V here at the barrier is 4 meters per second. Let's check the question that comes thereafter. It says use energy principles to calculate the magnitude of the average frictional force. Mr. Taper, you calculated everything right. You used now work energy theorem. But the problem is you did not now check that actually the question is asking for the frictional force, not the work done by friction. So you calculated work done by friction nicely. The only thing that we're supposed to do was just to divide your answer by 10, which is just now the displacement covered by the object. So that is the only element that you missed. So on the previous one, I used work done by NC. So in this instance, I'm going to use work energy theorem. But remember what we said. When the object now comes here at the 2 kg, we must draw that free body diagram for 2 kg. Even though the examiner did not ask. So what are we going to have? It's easy. We are going to have our normal force. We are also going to have our FW, and we are also going to have the frictional force. And maybe I must just make this thing also black. So let me label everything I have. It's F normal, it's FW, and this is now my frictional force. I do not have the force applied. Why? Remember, it was sliding on its own from P, Q, R. So I do not have what? Force applied. So the only force that is doing work here is what? Force of friction. So I can easily say now, when I want to use at 19.3, work net is equals to change in EK. What is work net? Work net is actually work done by friction, because that is the only force that is acting on the object. So if, with that being said, what is work done by friction? It's friction multiplied by delta x cos of theta. And what is this here? It is half mv squared final minus half mv squared initial. Then it basically says it is just a matter of substituting. So we want Fk, no problem, multiply by 10, that is the displacement. And because friction is acting in an opposite direction with the displacement, we are going to use now cos of 180. What do we know? Half. And what is the mass? 2. V final, it's 4 squared minus 2 multiplied by 9.90 squared. Hence, it was important for me to highlight the initial velocity at Q and the final velocity at R. Then you do the mathematics and the manipulation. You find that now Fk is actually 8,2 newtons. 8,2 newtons. So you guys did it nicely. You guys did it nicely. The only mistake I found was when Tabang did not, Tapelo did not now add the fact that we actually have the work done by friction and the displacement that is equals to 10. So whatever answer you got, you should have just now, what's the weight? Divided it by 10, and then you're going to get the correct answer. It's not a train smash. That is the reason why we need now to read the question at least 2 times to be in the lookout of, do I understand what the examiner is actually asking me? Now, with that being said, it basically says the 19.3, it's done in detail. It is explained. Let's check if we can't do now 19.4. The barrier exerts an impulse. We are given now an impulse to the left on the box and strikes the barrier. So what is it that the examiner is doing here? He is combining the concepts of momentum and impulse with what? Concepts of work, energy, and power. So the concepts of momentum taught us that 19.4. Impulse is actually F net multiplied by changing T, which just gives us now the change in momentum. Let me write this P correctly. That is the equation we have for impulse. But what did we say? We said now everything on this side, it actually represents the impulse. So what are we going to do here? It's very easy. We are just going to substitute minus 14 because we want to assume that left is always negative. But now that is one deciding to choose now right as positive. So remember, we are working with vectors because now there is a force involved, which is F net. So direction is important. We are working with momentum, which is also a vector quantity. So a choice of direction is important. So I usually make my life very easy because plus minus, plus minus, and then I say this one is east, this one is west, this one is south, this one is north. So this Cartesian plane that I have, I always try to use it in all the calculations that I work with that has vectors in it. So it basically says now I know changing P is actually M V final minus V initial. That becomes easy because I know my mass is 2 kg. I want now the V final that actually hits the barrier before. That will be now V final minus the 4 that was given because we want the rebouncing velocity thereof. Then you do your mathematics, you will find that V final is something like minus 3. So V final is equals to minus 3. V final is equals to minus 3 meters per second. But we did not answer the question. Why? Because the question says calculate the change in kinetic energy of the box after striking the barrier. So this is now what? This is the final velocity after bouncing off. I can easily say bouncing off the barrier. So we have two situations here. We have our barrier, the ball is coming here, it hits with 4 meters per second, and it bounces off now with 3 meters per second. That is what is happening at 19.4. So what can we do now? Basically, it's easy. Change in kinetic energy is just half mv squared final minus half mv squared initial. You just substitute your values. That is now 2. V final is minus 3 squared. Okay, even if you do not include that because energy is a scalar quantity, minus now half of 2, and V initial was given as 4 meters per second squared, and your final answer will be something like negative 7 joules. And one will just say change in EK is just equals to 7 joules. But what is the interpretation of this negative answer here? This negative answer basically tells us that we have frictional force that is actually doing the negative work. Remember, work and energy, they use the same symbol of joules, so we can associate that change in energy with now the change in work that is being done on the object. So the negative answer emphasizes that we have now what? We have a negative work being done on the object. So ladies and gentlemen, with that being said, that brings us to the end of question 19. I am going to give you your 30 seconds for you to ask me questions relating to this one. Please ask your questions such that we can know that we are on the same path. Thank you very much. I don't see any hands. I don't see any comments in the chat. So that basically says everybody is fine. Let me just quickly ask Mr. Sekwi, what are you taking from this particular problem? What is it that you are not aware of that you feel now you will be maybe applying the principles more?
So it was like applying the formulas with the questions. So that's why it took so long to calculate. I used some of the formulas, a lot of formulas, by using a pencil, but then I found the right formula.
Thank you very
And
much. So it's just an issue of one knowing, saving time in terms of which formulas are going to be of assistance. So
yes,
later on, just remind me, I must send you a formula sheet that you can usually refer to every time when you work with physical sciences. Remember, the formula sheet will be there. So having a formula sheet when you practice, it's not a crime. You don't have to memorize the questions because the formula sheet will be given. So let's already start practicing the usage of the formula sheet. So remind me to share a formula sheet with you that every time when you talk paper one, paper two, you can easily refer to it. Thank you very much. Tapelo, what's your take on this question 19?
thanks.
Uh, I'm okay. So my problem is, and what I have realized is that I don't read the question with understanding.
Thank you very much. So it
And then
basically, yeah. And then
I forgot that direction is very important.
when
You see.
working with a
So
vector
that,
quantity.
okay. Yes, sir.
Okay.
So that is what my problem is.
All right. Now, thank you
But
very.
next time,
Next time you are aware, that is the reason we need to practice and practice. Have such questions such that you
yes,
can outline the possible mistakes. So these things we know. Let's just read the question with understanding. Let's use the applicable formula. Let's just remember that every time when working with a vector, direction is very, very important. Now, with that being said, the last one for the day, I think it should be this one. And it's 14 marks. So let me give you your 14 minutes such that now immediately after this one, we know that we are done with today's session. Thank you very much. That's basically it with question 18. Let me quickly check. Tapelo, how far are you? Do you need extra 2 minutes?
I'm sending right now, sir.
Thank you very much. Ra leboga.
Yes, sir. Can I please have 2 minutes, sir? I'm on
Two,
the last question.
2 minutes, no problem. Thank you.
So I'm not yet done, but can I please send you what I've finished, sir?
Please, such that you can save time, please send what you have and we'll look into it. Thank you very much for the answer sent. Let's not waste time and read the question in detail. Let's see what it says. A demolition ball used by the crane to break the wall of a building. The demolition ball has a mass of 1250 kg, lifted at point R at a height of 5,8 above its lowest point, position in 60 seconds. Ignore air friction. Very, very important. Ignore air friction. Now let's check. Define the term power. It is a definition and easy 2 marks. Power is the rate at which work is done. Now let's go to 18. Okay, let me maybe write it here for purpose of space. It says now calculate the average force, the average power dissipated by the crane in lifting the demolition ball at point R. Let's see what we have. P is equals to sorry, I'm just fixing my pen here. P is equals to W over T. That is the formula that we know. Now one will ask, does this mean now I must calculate the work first? Definitely. You must calculate work first because you are not given any work anywhere. So it means now even if the formula says P over let me just clean it up. Even though the equation says we are at 18.2, P is equals to W over changing T. But we said W is actually work or it's actually energy. That is what we said. So, Mr. Sekwi, the
I made a
equation,
mistake.
yes, sir.
I didn't see. Yes.
Yes. So it is important to realize that work is actually energy. So it is important to realize that now we can first maybe calculate the energy. What energy do we have here? We have EP is equals to mgh. That will be now the mass, which is 1250 multiply by 9.8, and we are given the height there as 5,8. So whatever answer we get here, we are going to move it to P is equals to W over changing T, because now we do not have any work given somewhere. So the idea here was, let's get the final answer. Let me quickly get my calculator, which is 1250 multiply by 9.8 multiply by 5.8, and this gives me something like 71050 joules. So this answer, I am going to substitute it there. Then it makes it easy for me to know that now fine, P is actually 71050 divided by the 60 seconds. Divide this answer by 60, it will give you something like 1184,17 watts with the SI unit. That is now correct. It is 3 marks, yes. You only get 1 mark for the correct formula. Let me use red. 1 mark for the correct substitution and 1 mark for the correct final answer with the correct SI unit. So that is very, very, very important. So the equation, it says work divided by time. So work is just energy. So we needed to calculate the energy first. That was very, very important. If you want to calculate work, then it basically says you can use mg cos theta, then you get your 1250 multiplied by 9.8, and then you just multiply that by cos of 90. Sorry, cos of 0, then that will give you another option. So there are many ways of doing this. The demolition ball is released from point R and it strikes the wall at the lowest point of its swing. The ball then moves 0.25 meters horizontally into the wall before coming to rest. So this says V final is equals to 0. What else can I know? It is also starting from 0. Then I will look into the questions thereof. Define the term conservative force. A conservative force is a force which the work done in moving two objects is dependent on the path taken. Easy. Is the force which the wall exerts on a ball is a conservative or a non-conservative force? Is a force which the wall exerts on the ball a conservative or a non-conservative force? Let's check. The force that is going to be applied here, it is going to be obviously an applied force, which is now back to what the force in the crane is exactly applying. So that force, because it is an applied force, remember, it must be a non-conservative force. It is as simple as that. State the energy conversion that takes place during the downward swing of the demolition of the ball. So at 18.6, it is starting from potential energy to kinetic energy. That is now very easy to understand, because remember, the demolition ball was hanging 5.8 meters above, and then it was released, it started moving, and then after it has started moving, it basically says it's changing its potential energy to kinetic energy. Now let's look at 18 point, oh, this is 18.5. Let's look at 18.6. At 18.6, using energy principles, calculate the magnitude of the average force exerted on the ball while it is moving into the wall. Now, we do not have friction. We're told ignore air friction. So once the examiner says ignore air friction, what is the examiner saying? The examiner is saying we can use conservation of mechanical energy. But conservation of mechanical energy will not assist us to calculate the average force. So the only principle that works with forces is work energy theory. But I am going to use now the two combined in order for one to exactly understand what is happening. So I am going to say, let's start from R to the wall. R to the wall. Let me use black. What is happening? We have EK plus EP at R. And we have now EK plus EP at the bottom. This is now when it hits the wall. What do we know about this? We know that EK, because it is starting from rest, will be 0. And EP, we calculated EP, which is just 1250 multiplied by 9.8. That is now at R, multiplied by 5.8. I am doing this substitution because that is what the examiners want to see. But now we are told again that when it hits the wall, it is coming to rest. So what does that say now? It says now when it comes to rest, that will be our E final. We are going to need it for the second part of the equation. But now after hitting the wall, it basically says MGH becomes 0. So let me first start by saying I want to know the EK at the bottom plus now MGH, which is 1250 multiply by 9.8, but it's no longer at that height of 5.8. It is actually now at 0 because it has covered the distance that was supposed to cover. So, or the height that it was supposed now to cover. So after doing all the manipulation and everything, this 0 cancels 0, and then you are basically left with EK that is also equals to 71050 joules. But one will ask, why did that Nambane calculate that EK? Because I want to get to work net, which is just changing EK. So what is changing EK? It is basically EK final minus EK initial. What is work net? The only force that is acting there, it will be the force of the wall. So I am going to call it now force of the wall multiply by changing x cos now of theta. That is the only formula I know of work. Then one can easily say f of the wall multiply by 0.25, then cos of 180. What is EK final? EK final will be 0. How can one tell it is coming to rest? So I am going to say half the mass is given as 1250 multiplied by 0, half 1250, which is the mass, multiplied by 0 squared, minus now that EK that we calculated at the top, which is just 71050. Let me check. Any questions so far? Yes, Rea Leboga.
Sir, there at 18.2, sir, we got the same answer as calculating the EK of 71,
050.
Can we also use that, or is it in the test? Is it going to be different, or is it going to be the same as calculating it?
It will depend
Can we?
on what the examiner actually gives you. But the key idea is you work with the data that is given. Remember these questions because they were asked previously. The examiners are not going to repeat these questions again. But the
Yes.
concepts and the principles will still be the same. So my advice will be look into the information that is given. It does not necessarily mean now at 18.2 and 18.6 when we calculate the energy should necessarily be the same. No, it is according to the information that was given to us.
Yes, sir. Thank you, sir.
Thank you very much, Rea Leboga. So when we have this information there, it basically says understanding the question. Then we can do the mathematics and everything, and eventually you have f of the wall that is now equals to 284 200 newtons, and then this will give you your nice five 5 marks. So this question is somehow a little bit different from the ones that we've been doing, but this one is the one that is now testing the actual understanding of the concepts. Because, like I did say, what is happening is we build from easy to more complex situations. So, this question on its own, it is a question that allows us to know now that integration of topics is important. Integration now of principles is also very, very important. Ladies and gentlemen, with that being said, let me check. Tapelo, are you okay with everything that we did today? And give me the reflection of today's lesson such that we can be able to close the session.
Okay, so I have learned a lot, and then I can see that I really improved.
Thank you very much. Re a leboga sekwi.
So I learned a lot by looking and fixing my mistakes where I was wrong, sir.
Thank you very much. So, guys, with that being said, thank you very much. Let's meet again Wednesday, Thursday next week. And then I'm not sure, maybe I should give you two exercises that will be part of the homework for next week. And then we can finish off work, energy, and power because there will be nothing else to ask here. It will be just me encouraging you to practice and practice such that you can basically understand and check the questions how they are being asked. Then immediately thereafter, we can go to chemical change. The reason why we must go for chemical change is because chemical change, it's 92 marks out of 150. So if we can try and finish that sooner, it is going to give us more time to revise maybe term one topics. So with that being said, gentlemen, thank you very much and have a lovely afternoon.
Thank you, sir.
Thank you so much, sir. Enjoy your day.
Thank you very much.